Hello, everyone. Just waiting for a minute or two before everyone else joins this conference. Good to have you here, and we'll be starting in just a few minutes. Okay, hello again, everyone. Good to have you here today or tonight in my case. A few words before we begin. Please, would like to request that you keep your microphones muted. I'm sure you will have questions in the course of this presentation, but we're going to take these questions in the chat, in the Zoom text. So it's just easier to keep track of all the questions and we don't miss any. So whichever questions you may have, just type it in the chat. There is a team here with me that will answer these questions as we go. Now, again, if you require a certificate of attendance here of some sort, this can be also issued by our managers. So write to us, let us know if you need one. To all of you as well, there is a 5% discount on the two machines that I will be presenting towards the end of this webinar. And you can also get this from our team by requesting that from them. Okay. All right. I think this presentation is going to be a bit on the long side, so might as well grab yourself a coffee and a cookie or a sandwich or something and get comfortable. And I guess we should begin and get into it. So today we're talking about bitumen and asphalt. I know these terms are, North America prefers asphalt. I guess I'm more used to bitumen. So whenever I say bitumen, my North American listeners here can substitute asphalt. It's basically the same thing, synonymous for me here. Okay, so bitumen, it's among the most commonly used organic binders. Has valuable properties for construction. It's water resistant. It's resistant to many chemicals, softens when heated, so easier to apply. It sticks well to wood, stone, metal, plastic, and its viscosity grows really fast when it's cooling down. So that makes it very convenient. In road construction, which is the, and we can go to the next slide. Next slide, please. Thanks. So in road construction, bitumen is used mainly as a binder in the construction and repair of pavement and hard road surfaces. And bitumen that we use on the roads is divided into viscous and liquid types. Okay, viscous bitumen is used for surface treatment of pavement, for impregnation of crushed stone materials, in the production of asphalt concrete and bitumen mineral mixtures in various climatic zones and various climates in the world. Liquid bitumen is used as a binding material in the construction of road surfaces and pavements, and also for many types of road works and preparation of bitumen mineral mixes with cold laying, and for surface treatment of gravel roads and various crushed stone surfaces. Okay? So the leading field of application of bitumen is basically the construction, repair of roads, residential buildings, industrial facilities, and airports. It's also a very good hydro insulator, so it is often used to prevent any damage from moisture to various structures. Next slide, please. Right, so under normal conditions, so at normal room temperature, bitumen is a solid or very highly viscous material. It is not very usable for any application. So to use it, we must make it liquid. And we can do this in one of three ways. We might heat it to some like 100, 200 degrees Celsius until it turns sufficiently liquid, and then we can apply and mix it as we wish. Asphalt concrete mixtures prepared with this hot bitumen, as a rule, are stored, transported, and applied hot, probably with the exception of cold stored bitumen mineral mixtures, which are prepared with heating, but still stored and applied cold. We can dilute bitumen with refined oil products, such as various solvents, kerosene, diesel fuel, gasoline, etc. And that makes this bitumen or asphalt liquid. And the third way, and the one we will be focusing on today, is emulsification. We use water, and we mix bitumen with water, adding in a surfactant, or surfactant also known as emulsifier. And as a result of this emulsification, we get a bitumen emulsion, which is still liquid even at ordinary room temperatures. So when paving roads using hot and warm asphalt concrete mixtures that are prepared with hot bitumen, and that would include crushed stone mastic mixtures or hot compacted or cast mixtures, the road surface hardens and gains strength as the applied mixture cools down. And this method has both advantages and limitations. And the advantages include the possibility of making asphalt concrete with high strength when using high viscosity bitumen for roads with heavy traffic. The disadvantages are the significant amounts of energy that are necessary to heat mineral materials in the production of these hot mixes. And then there is a limited period of time for application of this material on the road. And of course, there is the environmental impact, which is not at all good. There is an environmental hazard throughout the production application cycle. So asphalt pavements that are made with liquefied bitumen with solvents gain strength not because of cooling, but because of the evaporation of these solvents. And these are hydrocarbon fractions, volatile, very volatile. So it can be, first of all, they're expensive. Second of all, they have a certain environmental effects. They're toxic, and there is a fire hazard. They're flammable. So for asphalt concrete and other road building mixtures that are prepared with emulsified bitumen, the cast emulsion mineral mixture, slurry seal, microsurfacing, cold asphalt, that gains strength in the process of the emulsion breaking back into its ingredients, that is bitumen and water. So this breaking reaction happens due to a chemical interaction or physical interaction of the emulsifier surfactant with the mineral surface. And this method of using the emulsions doesn't require much heating, and it can be used in much colder weather with cold materials, and even when the materials are wet. So we immediately eliminate a lot of the energy requirements and reduce the energy cost of the process by 40 or 50% even compared to the hot process. Okay, next slide, please. Right. So let's talk a little bit about the advantages of bitumen emulsions very quickly. So the viscosity is very low. So, and that means that such material can fill small pores, small cracks, ensures it permeates the surface very well. It has very good adhesion to surfaces of various structures and various nature, be it acidic or alkaline minerals and metals. It can be used in low temperatures and in high humidity by improving adhesion forces of the binder to the surface of the stone materials. And in this case, the moisture content of the inorganic material even plays a positive role when it's combined with a bitumen emulsion. Okay, reducing the viscosity improves the accuracy of portioning the binder, so we can apply this more precisely. Also, it saves fuel or electricity because we don't need to heat the mixture so much. And of course, there is the reduction of the harmful emissions into the atmosphere and less fire and explosion hazard, and also burns. So it's hot. Regular bitumen is hot, so people can get burned. And with emulsions, that's not a factor. Okay, so at this time, hot bitumen is increasingly being replaced by bitumen emulsions, both in road construction and in industrial and civil construction as well. Next slide, please. So let's, okay, so what is an emulsion? Okay, it's a dark brown liquid. It's made by dispersing bitumen droplets, particles in water. And this dispersion is counteracted by the internal cohesion and viscosity of bitumen and by the surface tension forces, interfacial tension, which resists the formation of this new interface. And while we keep mixing this mixture, it's okay. But once we stop the emulsion without any, if we don't add special chemicals, it just breaks down into water and bitumen really quickly. So to keep the components mixed, we use a surfactant, and that surfactant prevents or slows down the separation of the phases of the emulsion. And the way it works is the emulsion molecule is polar. One end is compatible with bitumen particles, and the other part of the molecule is repelled by other molecules of the same emulsifier. So bitumen particles are surrounded in a way, a force field of a kind, and they don't stick together and stay apart in the emulsion. Next slide, please. Also, apart from bitumen, water, and a surfactant, emulsion contains a stabilizer. It can contain acid, various solvents, and thinners. And acid is necessary to improve the stability of the emulsion. In most cases, we'd use hydrochloric acid, orthophosphoric acid, and acetic acids. For anionic emulsions, however, we use alkalis. So same function, but different pH. Okay. Stabilizers are used to reduce the changes in the physical and chemical properties of the emulsion during storage and use. And that would be maybe calcium chloride solution, very weak, 0.05 to 0.1% of this solution. Solvents are used to create a more homogeneous system, and they are light oil fractions with a boiling point of about 140 C in the amount of maybe 0.5 to 3% of weight. And we also can use thinners, and these include various gas oils, oil fractions, etc. And there is a wide range of those. We can use anywhere from 5 to 30% by weight. What they do is they increase the penetration of bitumen to the required parameter, to the required value. So we have a stable liquid emulsion in the end. Also very important, adhesive additives. They improve, as the name implies, the adhesive properties of the emulsion. And when making emulsions, there can be polymers and other modifying additives. And polymer modified bitumen emulsion is basically made with either made with modified bitumen or it contains modifying additives. And these include latex, polyethylene, epoxy resin, synthetic rubber, synthetic resin, etc., things of that nature. And modification of bitumen emulsion can be done in two ways. First, we can introduce a modifying additive into the water phase of the emulsion, or we can introduce it directly into the emulsion during the production. Or the second way is to use modified bitumen for the production of the emulsion. Okay. All right, next slide, please. So now that we have talked about what the emulsion is, let's talk about the classes of the emulsion. And depending on the type, we can have direct emulsions, and these are oil in water emulsions. There is the inverted type of emulsion, a water in oil emulsion. That's when water is the dispersed phase and is dispersed in bitumen, which becomes the dispersion medium. And it should be noted that during the production process, both types of emulsions can be formed simultaneously, especially if we use double-purpose surfactants. And what type of emulsion will eventually turn out depends on the nature of the bitumen, the pH of the water medium, and the ratio of the volumes of the phases. So in order for the surfactant to function as such at the oil-water interface, so to be absorbed, we must have an affinity of the same water for both phases. And if this condition is not met, the emulsifier will move from the interface to the phase for which its affinity is greater. And typical examples of such well-balanced substances are some soaps, and the molecules of them have an organic tail with a strong affinity for oil and an ionized head with a significant affinity for water. With very short tails, the affinity for water predominates and the molecule is absorbed into the water, which makes the emulsifier poorly balanced. With very long tails, the affinity for oil dominates, and the emulsifier again is poorly balanced. But with a certain average ratio of the lengths of the head and tail, there is an optimal balance and the best stabilizing effect that can be achieved. And for the purpose of clarity, we can think of this behavior of the emulsifier molecules that are differently based in their polarity like this here. In the first column, in the bottom right, we see molecules with the predominant polar part. In the second, there are molecules with a predominantly non-polar part. And in the third column, the polar and non-polar parts are of the same strength. Okay. So if the emulsifier is highly hydrophilic or very oleophilic, is practically soluble only in one of the phases forming the emulsion, then basically at any ratio of phase volumes, the emulsion will only be of one type. Okay. So for some emulsifiers, it's possible to make both direct and inverse emulsions with the same phase ratio and without changing the pH of the medium. It's only necessary to change the volume of the emulsifier in the system. So with, for example, a small amount of emulsifier, we get inverse water in oil emulsion. As we increase the amount of the emulsifier in the mix, we get oil in water emulsion. And when we keep increasing the concentration of the surfactant, the dispersion of the emulsion increases, and then it reaches a certain limit, and then we get inverted emulsion again. Okay. Next slide, please. So here's how emulsions are classified depending on the concentration of bitumen. Basically, low concentration emulsions contain up to 40% of bitumen, concentrated contain up to 74% bitumen, and highly concentrated go above 74% of bitumen. And currently, it's safe to say that only the first two types are used in road construction. Highly concentrated emulsions are used extremely rarely and are currently practically not produced. But there is some promise in them for this production, primarily where it's necessary to transport emulsions over long distances. So there are benefits to that. Next slide, please. And there are classes of emulsions depending on the emulsifier. So this can be anionic with the anionic surfactant, cationic, again, this cationic surfactants used for those, There are amphoteric emulsions with double-purpose emulsifiers, such compounds that ionize and act differently in water solutions depending on the pH of the medium. They exhibit the properties of cationic surfactants in acidic solutions and anionic surfactants in alkaline solutions. Then there are non-ionic that have surface active properties but don't dissociate into ions in water solutions. And there are emulsions with solid emulsifiers. Okay, so emulsions of the inverse type, depending on the nature of the emulsifiers, are usually not separated into classes traditionally, but now when it became possible to have a large selection of emulsifiers, we can divide them into some subcategories. There are surfactant emulsions, solid emulsifier emulsions, and emulsions based on non-ionic emulsifiers. And this type of inverse emulsion is still under development, but again, has its its promises, especially in the case of using an emulsifier that's sensitive to temperature changes during the preparation or application of such emulsion. Next slide, please. Okay, so in road construction practice, the most common emulsions are of direct type. They be primarily anionic or cationic class. Therefore, the classifications of these emulsions in the United States is based on the rate of mixture formation, of setting based on this emulsion, and the rate of breaking of the emulsion. So how soon the bitumen is released from the emulsion and achieves its original properties and forms a continuous film. And there are rapid set emulsions, medium set, slow set, and quick set emulsions. And for the convenience of classification, there is a special international system of symbols. Makes it a lot easier for users to choose the required type and grade of a bitumen emulsion. Now, first of all, the type of emulsion is indicated by the rate of setting. For example, a rapid set emulsion is called RS, and then either letter C can be in front of the name. That would mean that it's a cationic emulsion, or if there is no letter C, that means it's an anionic emulsion. So RS is a rapid set anionic emulsion, and CRS is a rapid set cationic emulsion. Then the viscosity of the emulsion is indicated on a relative scale from 1 to 2. 1 indicates that emulsion is more viscous than 2. And for some brands of emulsions, the letters H or S also appear in designation, indicating hard or soft bitumen used for the emulsion. So for some brands of anionic emulsions, HF, letters HF are used. That means high float emulsion, and those emulsions create a thick bitumen film on the mineral material. So, for example, if you have a designation such as HFMS-2H, that means it's an anionic medium set emulsion based on hard bitumen with low viscosity. And it's a high float emulsion. And if we have CSS-1S, that means it's a cationic slow setting emulsion with a high viscosity, and it's based on soft bitumen, basically bitumen diluted with a thinner. Okay, there are also superstable emulsions. Those include emulsions based on solid emulsifiers, also known as pastes. And the expansion of the use of polymer modified bitumen was also reflected in this system by adding letter P at the end of the designation of the emulsion name. For example, if we have HFRS-2SP, that means it's an anionic, rapid setting, high float emulsion of low viscosity, and is based on thinned polymer modified bitumen. Next slide, please. So bitumen emulsions pretty much perform two main functions. The binding function is the use of an emulsion to bind mineral materials and their particles together, which is a prerequisite for the production of asphalt mixtures, such as emulsion mineral or black crushed stone or cold mixes and what have you. The protective function is to protect materials and surfaces against the effects of aggressive media or the elements, so, water, salts, etc. Bitumen emulsions can also be used for quite a wide range of road construction works. They can be used for surface treatment, for cold storage mixes, for creation of traction layers, tech layers, pothole repairs, and thin film protective layers, etc. Okay. Next slide, please. So first, let's briefly touch on the subject of primer coats. Priming means the application of an emulsion by spraying it in the form of a thin layer, which ensures reliable adhesion of the asphalt mixture to the underlying base. For most types of pavement, be it concrete or anything else, the creation of a binding layer is not just desirable, it's also necessary. So one of the types of priming is the application of the so-called initial coating, when a slow emulsion with a bitumen content, of 55 to 60% is sprayed onto a granular base to prepare it for the application of an asphalt concrete mix. Next slide, please. Surface treatment is performed on a new asphalt concrete and various types of black and cement concrete pavements, as well as on used pavements, to ensure the necessary adhesion and traction between the wheels of vehicles and the pavement surface, and also to increase the service life of the pavement. So the layer created by surface treatment serves to give the coating certain roughness and water resistance, wear resistance and strength as well, and density. So we're talking here about both an inexpensive single treatment of secondary road surface and the creation of wear resistant surfaces on large major roads with relatively high traffic loads. And it's important to know the strength of the base is important to the durability of the surface that we treat. Okay. Next slide, please. Okay, there's crushed stone impregnation. That means the construction of layers, bases, and coatings and pavements by multiple scattering of crushed stone of various fraction, compaction of that stone material, and its permeation with emulsion. Usually done twice, okay, with slow breaking emulsion that contains 50 to 65% bitumen on average. There is the patch repairs, and the use of bitumen emulsion does greatly simplify the repair process, and it allows operations to continue well into late autumn and start early in spring with air temperatures just 5 degrees above 0 Celsius. So when using emulsions, it's possible to apply them on wet materials because cationic bitumen emulsions ensure pretty fast formation of a binder film and high adhesion of this film to the surface of most aggregates, even wet, and generally rather good quality of the repair works. Next slide, please. And okay, there are other technologies as well. There's slurry seal, microsurfacing, multimac, and cold recycling. And slurry seal is a method of applying thin layers over existing pavement. And this cold mixture consists of dense mineral material with a filler, usually Portland cement. It's mixed to a uniform consistency with bitumen emulsion water. And after the so-called setting time, the surface becomes impermeable to water. The coefficient of friction is improved for vehicles, and the old coating is protected from water, oxidation, and further breakup. And with the help of slurry seal, rutting and longitudinal deformations of the profile can be compensated to a degree. So since there are practically no voids in this hardened mass, it resists squeezing very well under vehicle wheels. And after coating is complete, traffic can resume after about 1 to 4 hours after work. Okay. Microsurfacing emerged as a further development on the slurry seal method. It's a method of creating a rather thick and durable coating for the surface. Microsurfacing can be applied in 2 layers of 25 to 30 millimeters in thickness. And in some cases, the total thickness reaches actually 75 millimeters. With this technology, larger stone materials used, and it's bound even more strongly than in slurry seal. And the coating can withstand significant physical loads without deformation. And to further increase the shear stability, latex is used in this process. Next slide, please. Okay, so microsurface is used to eliminate rutting and to fix minor profile defects. It's used to expand shoulders on the roads. And basically, it can be used in any situation where slurry seal can be used. Okay? So it's one of the fast traffic solutions, meaning that these emulsions set just 30 to 60 minutes after the work is done. So if the coating is done in 2 passes, then first one closes and seals the cracks, smooths out the surface, And then the second layer is applied no earlier than in 1 day after the first one. And when this work is done, traffic can resume in 30 minutes. But it's recommended to limit the driving speed to 40 kilometers an hour. Would be what, 30 miles an hour or so for 1 hour after completion of work. So both slurry seal and microsurfaces imply a fairly quick application at a speed of 3 to 6 kilometers per hour. Both technologies allow to quickly restore the pavement surface, and both act as protective layers to prevent wear and destruction of the top layer of the pavement. And they can both withstand sufficient and heavy traffic loads and intensities. And the average service life of such pavement is about 3 years. Okay, next slide, please. All right. Multimac. It's a thin layer coating that has a function of a protective layer or layers. It cements the damaged base, fills all cracks and voids with a bitumen mineral mixture, and it evens out any deformations in the pavement. So this mixture is prepared and distributed by a special machine that is equipped with the very precise digital computerized system for portioning of components. And Multimac does not require any special sealing, so traffic is possible within 20 or 40 minutes after the work is done. So recycling, or cold recycling, is a technology of straightening soils, stone materials, and asphalt granulates that are obtained as a result of crushing asphalt scrap and various other binders by cutting and mixing it directly on the road. Next slide, please. Right, so sealing cracks in the pavement can also be done using bitumen emulsions. The cracks are filled with an emulsion mixed with fine-grained sand, leaving a few millimeters to the surface. And after solidification, the remaining volumes filled in with straight unmixed emulsion without the sand. And then sand is applied over the top of that to protect this material from being carried away by vehicles and wheels. And bitumen emulsion can also be used to reinforce slopes, reinforced sandy surfaces to prevent dust formation, remove dust from unreinforced materials and dirt roads. And in many cases, emulsions can also be used for waterproofing. Okay. Next slide, please. So now that we know that emulsions are good, let's talk about how to make them. And bitumen emulsions are usually made using a colloid mill, but they can also be prepared using other dispersing devices. In a mill, an emulsion is produced by passing a mixture of hot bitumen and a water phase, a solution, between a rotor and a stator of the mill. And the rotor and the stator both have slots or teeth that create a very turbulent flow and very high shear forces. And for the preparation of bitumen emulsion, either batch or continuous production plants can be used. Batch production process consists of 2 stages. The first would be the preparation of what we call a water phase, also known as soap phase sometimes, and the actual production of emulsion. The water phase is prepared in a tank with heated water, emulsifier, acid or alkali, and other additives. And the solution is mixed. And then at the stage of actual emulsion production, bitumen and this water phase are mixed in a colloid mill in a certain proportion. So if we need to add a solvent to the mix, then we need a bitumen portioning tank. But if the solvent is dosed, the solvent can be dosed and injected into the bitumen stream directly and continuously as well. So in a batch unit, there are only a few material streams involved in the actual production process, which allows manual control. And the exact dosage of the various components plays a very important role in ensuring the quality of this emulsion. The use of fully automated or semi-automated controls provides a more efficient production process, decreasing the chance for operator error, however. So chemical additives that are used in the process can be hazardous to health or corrosive to metal, and it means that it's better to use completely closed and sealed dosing systems, which is better compared to open tanks and portable pumps. That's from the viewpoint of safety and environmental protection standards. Okay. Next slide, please. Right, there is also the continuous production process. basically water heating and portioning of all the materials are done continuously using separate portioning and dosing pumps for each of the material streams, and batch tanks are not used. Instead, a water phase feed system is designed to provide a sufficient time interval for the reaction between the chemical additives to neutralize and dissolve until the water phase is combined with bitumen. And this process requires the use of automated control with flow meters for the dosage of all product streams, with the exception of acid. The supply of acid is controlled based on the pH of the water phase that is measured. Now, when making an emulsion, it's possible to use various polymer modifiers such as latex, SBS, and other additives. And in this case, it becomes necessary to equip the plant with additional components, as well as to implement appropriate solutions in terms of technology process. Latex, for example, it's sensitive to certain factors that can cause it to break, and it clogs pumps and pipelines. For SBS polymers, it's usually necessary for the emulsion output to be at a temperature above the boiling point of water, which in turn requires certain overpressure, and then the resulting product is cooled before it's fed into the storage tank under normal atmospheric pressure. Okay, next slide, please. So today we're going to show you how this works in practice by giving you a glimpse of the two globe core machines, one that makes 2 cubic meters of emulsion an hour, and the other makes 8 cubic meters of emulsion an hour. And when we're done with this glorious PowerPoint presentation, we're actually going to take you to one of our production facilities and show you 2 of these plants live. Meaning they're not in operation, but they're, the finished plants that, we can demonstrate you the plants and how they work. Okay. Right. So here you can see our globe core plants in the next slide. Next slide now. A big table with specifications. I guess some of the things to pay particular attention to is the dimensions. The dimensions are, as you can see, quite compact. I believe they're all in metric, but so about 2 meters in length. It's about 6 feet in length or so. Just a little over 6 feet in width, and a little less than 6 feet in height for the smaller one. So yeah, there you go. So one is 2 to 3, and the other one is 8 cubic meters of emulsion per hour production. Okay. Next slide, please. Now. Right. So both plants are semi-automatic. They consist of several independent units that are connected by pipelines that are mounted on the same frame. And the plants can be divided into subsections. Basically, we have an emulsion preparation section and a water phase preparation section. And there's also the control system. Okay, next slide, please. So, okay, the emulsion preparation section is basically a 3-stage mixer with pipes, valves. There is a bitumen pump, and there is, of course, a rotor and mill. The components are equipped with heating jackets that are connected to a oil heating system, and this ensures that the hot oil passes through the entire system and maintains the temperature that is required for the emulsification process and handling of bitumen. And the water phase preparation section consists of a blend-in tank that is connected to all the pipes with all the indicators for the visual control of the flow. There are control valves and regulation valves, certain instruments, and all of this stuff is mounted on the same frame. So it's basically a self-contained skid, same frame as the emulsion preparation unit. And of course, the machines are equipped with all the necessary temperature and pressure sensors. There are several points where we take temperature measurements. It's water supply, blend supply, a bitumen feed to the plant, incoming bitumen, bitumen stream into the mixers, and the emulsion output. And we also measure pressure at the inlet, after the bitumen pump, and right before the mill. Okay, next slide. Next slide shows us the control panel, and it's based around a PLC controller, and there are also multifunctional meters and regulators. So one is a programmable logic controller PLC. The other one are simpler meter controllers. There's also protective and starting equipment inside. On the front panel of the device, there's a mode switch, and I'll talk about that in a minute. There are various control buttons, indicators, and on the top right, you can see a mimic diagram of the process with indicators to show the condition status of the technology process going on. So there are two modes of operation. There's manual mode and automatic mode. Manual is used primarily to check and adjust everything, adjust the process maybe if necessary. And there is the automatic mode for the normal production process. And this is chosen by pressing a mode button on the control panel. The PLC manages the operation of the plant in automatic modes. If something happens, if the parameters of the process go out beyond limits, the machine stops automatically. There is an alarm message, and the operator must acknowledge this message before operation can be resumed. Okay, and the PLC controller also manages the parameters of the water bitumen emulsion production process. It receives signals from these meters that receive signals in turn from the pressure and temperature sensors that I've mentioned above. All of the measurements are displayed on digital indicators of these corresponding meters. You will see a row of them on the bottom, just above the control buttons. There is a row of small displays. This is where the temperatures and pressures are displayed. Okay, on the right, this red thing you can see, it's an emulsifier tank heater. If you have a surfactant that comes in a barrel, you can place that on top of this heater if necessary, and supply hot oil from the same heating system into this heater. So if necessary, if required by the product formula, the emulsifier can be heated as well. Next slide, please. Here you can see an option for the plant. It's a latex injector. Our plants can be equipped with such a latex injection unit. We can also do production of emulsion using modified bitumen while providing a cooling of the emulsion by heat exchangers at the outlet of the unit to supply then this product into the finished product container. These plants allow production of all types of emulsions. It can be cationic, fast, medium, or slow set emulsions, and there can be anionic emulsions of the same types. That includes the H subtype, the emulsion based on hard bitumen. And all emulsions that are made with globe core units perfectly comply with the ASTM D 239798 and D 97798 standards for cationic and anionic emulsions, respectively. Okay. So, okay, next slide. Right, this is where the magic happens. Okay, this is the globe core hydrodynamic mixer, and this is the heart of our emulsion machines. The principle of operation of our machines is based on sequential mixing of components in hydrodynamic mixers at a certain pressure and a certain temperature. So, due to its design, the hydrodynamic mixer provides nearly instant mixing or even blending maybe of the components that come into it due to the kinetic energy of the bitumen stream and the speed of the flow. And so this component can be made small because of this. And the same principle is used for mixing the components of the water phase of bitumen with the solvent, and then bitumen phase and the water phase. And let's talk about the water phase here. Next slide, please. Right. So during the circulation of water in the tank, a pump draws in the necessary components through the mixer. The components are supplied one after another, opening the valves of the measuring containers to prepare a water solution of the emulsifier surfactant. So in our plant, we prepare a concentrated emulsifier solution, which instantly forms a water phase with specified characteristics, mixing in the required proportions with water that is heated to the process temperature. The water phase is made immediately before mixing with the bitumen phase, and it goes from the mixer of the water phase to the mixer of the bitumen emulsion directly. So the advantages of this method is precise portioning of components and precise adjustment of these concentrations. There is a significant reduction in mixing time and the elimination of any mixing tanks for homogenizing the product. Therefore, we're able to design a fairly small size plant. So the supply of each component is constantly adjusted during mixing, or can be constantly adjusted during mixing, to ensure the output of the finished product complies with the required parameters and the product formula. Another advantage of this process lies in the fact that the plants can work longer using one batch of water phase without the need to use large containers for blending, because the concentrate of the water phase is diluted by as much as 5 times before entering the emulsion mixer with just regular water. In addition, the mixer allows to take some physical load off the mill, which serves mainly to stabilize the already mixed emulsion. And this becomes apparent in terms of quality of the emulsion produced and in the lifetime of the mill itself, because less wear. So as a result, we get a homogenic product on the mill, mixed very thoroughly, and it's already, like I said, it's already a homogeneous liquid. And the final homogenization and stabilization of the emulsion takes place in the mill, and there we get the final product of good quality with all the required parameters. Next slide, please. This is the mill, and our mills are driven by belt drives, and that allows to achieve the required rotation speeds and peripheral speeds with a relatively small size. The mill itself is made of corrosion-resistant steel. It maximizes its wear resistance and service life, and the design is of a nozzle type, and it allows to create a maximum number of very small streams and very turbulent streams of liquid, and they're dispersed into droplets for mixing and stabilization in the end. Next slide, please. Right, so this is the process diagram for the production of bitumen emulsion. In addition to the plant in position 10, this process should also include a bitumen boiler, a bitumen pump, a heating station for oil to heat with a circulation pump to heat the plant, water tank, a thinner tank, an emulsion reservoir, a tank for the emulsion, a tank for the acid, an emulsion pump, and a compressor, and that is used for controlling of the pneumatically operated valves. Next slide, please. So let's look at the operation of this machine. Before everything starts, everything is warmed up to 110 degrees Celsius with the oil of the heating system that's provided by the heating station. All right. In the boiler, the bitumen boiler, bitumen is heated to 140 to 160 degrees Celsius. In the water tank, water is heated to 40 to 60 degrees Celsius and is supplied to the plant through an inlet filter. The water pump's turned on, and the water goes through the flow meter, a control valve, and it's circulated to stabilize the temperature in the water heating tank. And then another valve opens and supplies maybe 800 to 900 liters of water into the tank in position 1, and the actual amount depends on the product formula. Then acid is fed into the supply tank in position 2 from an external container, usually done by gravity. Then emulsifier is pumped from a barrel by hand pump into the tank in position 3, and if necessary, that emulsifier can be heated. All right, then the adhesive additive is pumped also from an external barrel by hand pump into the tank in position 4. Then the blending pump M4 is turned on, and water circulates through the C5 injection mixer, this hydrodynamic mixer that I've shown you a few minutes before, and a vacuum is generated in the injection chamber of the C5 mixer. And by opening valves, I don't know if you can see it on here, but V17, V18, and V19, the operator, according to the formula of the product, dissolves all components in the water. And after 30 minutes of operation of the M4 pump, the blend in this tank is ready. Okay. At the same time, at this time, I guess, hot bitumen from the bitumen boiler goes to the plant through the inlet filter and through another valve. And bitumen then circulates through a small loop and goes back into the boiler. And when the temperature at point T1 reaches 140 degrees Celsius, the bitumen pump M1 is turned on, the valve V27 is closed, and bitumen circulates through the big loop and goes back into the boiler again. So then the temperature at point T2 reaches 140. The operator sets the auto operating mode, selects whether operation will continue with or without the thinner, or with or without the latex, as the case may be, and then just presses the start button. And then the automatic cycle starts by switching on the M2 mill. In this case, with a time delay, all of the components of the plant begin switching on as programmed. And after switching of the bitumen mill V1, the bitumen enters the mixer nozzle at a pressure of 14 bar. And in the C1 mixer, the thinner and bitumen are pre-mixed. And the flow rate of the thinner is controlled by a flow meter R1 and adjusted with the control valve. In the C2 mixer, the bitumen and the water phase are mixed, and the water phase is first pre-mixed with the blend in the C6 mixer. And the percentage of water and blends controlled by flow meters R2 and R3, and they can be adjusted with the appropriate control valves. And then in the mixer C3, bitumen and water phase are mixed, and at the outlet of the mixer, if necessary, a latex solution is injected by the M6 pump, if necessary. And then the finished emulsion is stabilized by passing through the M2 mill. And the finished emulsion is collected and stored in a tank at a temperature of about 40 to 60 degrees Celsius. Okay. Next slide, please. And yeah, you can see here there's some of the pictures of emulsion plants in various parts of the world. We have quite a few of them operated now in Europe, in Asia, in Africa, in South America, etc. So quite popular on there. Next slide, please. Okay, now that I've briefly described the principle of operation, I can maybe summarize the main benefits of these plants. First, it's the fact that the plants can produce emulsions of all types. It can be cationic with various set rates, anionic, modified emulsions, whatever is necessary. The quality of the product is rather high. Maintenance is simplified because there is no or less mechanical mixing than in traditional technologies. Basically, most of the mixing is done in the hydrodynamic mixers, which don't have any moving rotating parts that are subject to wear. The equipment is small, so smaller equipment footprint is always good. The formula of the product can be adjusted on the fly, very easy to adjust, very flexible. Also high precision of dosage of ingredients. The machine can operate for a long time on one batch of water phase, because the water phase is prepared as a concentrate and then diluted as necessary just before the emulsification process with bitumen. You know, low core equipment has been around for a while, for a few decades, so also good quality and very customizable production rates. So whatever the client requires, maybe 1 cubic meter an hour or 20 cubic meter an hour emulsion, that can all be arranged. And that's about it. That concludes this PowerPoint part of this presentation, but stay tuned. We're going to do something interesting in a minute. Anyway, I hope this information was of interest. If you still have any questions, keep asking my colleagues there in the text window. And I guess we can move on to the final part of the presentation. Oksana.
Добрый день, меня зовут Станислав, и сегодня мы хотим вам предоставить, покажем две установки компании Globcore. Это для производства битумной эмульсии 1 куба в час и 8-кубовая установка
All right, let me present to you our engineer Stanislav, and he's here to present to you two of the globe core machines that I mentioned during this presentation. The one closer to us is a два куба, да? The first one is the 2 cubic meter an hour machine, as the other one, the one further away, the larger one, is 8 cubic meter an hour machine. So I will let Stas continue.
Как нам известно, это машины порционного типа действия, и суть их работы осуществляется тем, что происходит два процесса. Первый – это приготовление водной фазы, и второй – это смешение водной фазы с битумом.
So these are batch machines. As I mentioned during the presentation, there are two stages to this process. First is the production of water phase, and the second is emulsification of bitumen proper.
В этой части установки находится битумная часть, и я вам сейчас покажу, как это все обустроено.
Okay, so this side of the machine is the bitumen part, and we're going to show you briefly how it works.
Здесь находится вход битума в битумную линию.
This is the input of the bitumen to the bitumen line.
Подающий насос подает битум.
This is a supply pump for bitumen.
Подает на гидродинамический смеситель.
And this is the hydrodynamic mixer that bitumen goes to.
В этот смеситель параллельно вводится водная фаза.
At the same time, water phase is supplied to this mixer.
И потом готовый продукт идет на гомогенизацию в коллоидную линию.
And then this product goes for homogenization in the colloid mill.
Отсюда мы получаем уже готовую эмульсию.
And from here we get the output.
Как нам известно, для приготовления битума нужно вводить дополнительно компоненты, и сейчас я говорю о разжижителе.
And of course, for such emulsion, we need additional components, specifically in this case, thinner.
Это первое, что вводится в битум в этой точке, и если нам проследить линию.
So this is the first thing that is added to bitumen at this point, and if we follow this line,
мы можем увидеть шестеренный насос, который подает разжижитель.
we can see this gear pump here that supplies the thinner.
Также контроль и рецептура осуществляется с помощью ручного крана.
The control of the formula and the recipe is done with this manual regulation valve.
И поток мы можем здесь контролировать количество поданной жидкости.
Yeah, and we can see the flow of the thinner here on this flow meter for kerosene.
Как нам известно, водная фаза готовится в первую очередь, и сейчас я вам хочу продемонстрировать на нашей установке этот сосуд, в котором производится смешивание.
Anyway, water phase is prepared first, so we're going to demonstrate the water phase section now on this side of the machine.
Вся функциональная работа данной линии, водной линии, осуществляется с помощью вот этого насоса.
The water phase section is, I guess, the operation of the section is facilitated by this pump.
Функция его заключается в том, чтобы создавать циркуляцию воды во внешней емкости и подавать эту воду в бак установки.
So this pump circulates water through an external tank and supplies it to the blending tank of the machine.
И потом, когда купаж будет готовый, этот же насос подает в битумную линию готовую водную фазу.
So when this blend is ready, the same pump supplies the water phase into the bitumen line.
Водная линия водной фазы оборудована дополнительными контейнерами, которые предусматривают введение дополнительных компонентов.
And the water phase section has these extra containers for the other components.
Это может быть кислота или щелочь, эмульгатор и стабилизатор.
It can be acid or alkali or emulsifier and stabilizer.
В зависимости от рецептуры или пожеланий клиентов, эта компоновка может быть изменена.
But this is entirely customizable depending on specific customer needs and specific product formula. This arrangement can be changed.
Подаются дополнительные компоненты путем открытия этих ручных кранов.
So the components, these ingredients rather, are supplied by opening these manual valves.
Подаются в такой же гидродинамический смеситель, который есть и в битумной линии.
And they all go into the same hydrodynamic mixer that's installed in the same ones installed in the bitumen line.
Когда поток компонентов мы можем регулировать с помощью шкалы, которая здесь установлена.
We can regulate the portioning of the components with a scale that's installed in these little tanks.
Когда водная фаза, то есть купаж, приготовлен, уже готов, с помощью одного ручного крана, который находится вот здесь.
And when the blend is ready, there is this one manual valve right here.
А мы перекрываем, и этот же насос, как уже было сказано ранее.
So we close this valve, and this pumps begin supplying the blend into the bitumen section.
Да, подается все в гидродинамический смеситель, как я уже.
Everything and all ingredients are supplied into this hydrodynamic mixer.
Потом на выход, на гомогенизацию, и мы получаем готовый продукт.
And from the mixer, the emulsion goes into the mill for homogenation and then to the output. And that's when we get the finished product.
Здесь все очень наглядно и просто. Вы видите, все можно контролировать. И, соответственно, машина еще оборудована приборами.
The system is fairly simple and easy to operate. It also has a control panel that you can see right now.
Здесь обязательны датчики температуры и датчики давления, которые позволяют нам контролировать процесс.
You can see here the temperature sensor and the sensors and the pressure sensors.
Обязательно есть точка аварийного стопа. В случае непредвиденных ситуаций можно остановить машину вручную.
Of course, if anything bad happens during the process, there is an emergency stop button. You mash it and everything stops.
В принципе, по основным механизмам по этой установке все. Сейчас я вас прошу последовать со мной.
Now, if we can follow Stanislav to the larger machine.
Это установка для производства 8 кубов битума в час.
This is an 8 cubic meters per hour machine.
Сейчас эта машина на стадии досборки, поэтому некоторые маленькие дополнительные узлы отсутствуют. Но основной, в принципе, я смогу показать.
So yeah, this machine is in the very late stages of production. So some of these smaller parts are not yet installed, but it will be sufficient to demonstrate the principle anyway.
Эта машина также имеет те же компоненты, как и предыдущая. Это битумный насос подачи.
The basic makeup of the machine is the same. This is the bitumen supply pump.
Гидродинамический смеситель.
It's the hydrodynamic mixer.
Сюда вводится, подается водная фаза.
So water phase is supplied in here.
И это все идет в линию на коллоидную мельницу для гомогенизации.
And it all goes along with bitumen to the colloid mill for homogenation.
И отсюда мы имеем выход готового продукта.
And this is the output line.
В этой установке также оборудован канал подачи разжижителя через этот кран.
Here we also have a thinner supply through this valve.
И, соответственно, есть некоторое отличие от предыдущей установки. Это отличие в водной фазе, потому что здесь мы имеем два насоса.
And there is a slight difference from this smaller machine because for water phase, here we have two pumps instead of one.
Первый насос у нас производит закачку и циркуляцию воды с внешней емкости, закачку ее в нашу емкость, которая есть в установке.
So the first pump circulates water in the external tank and it supplies water into the blending tank.
Этот насос мы называем его купажный. С помощью него производится смешивание компонентов, циркуляция компонентов водной фазы в нашей емкости стандартной, которая есть, и подача концентрата, он готовит концентрат в битумную линию.
And this is what we call a blending pump. What it does, it takes the ingredients and creates the water phase and supplies it into the bitumen mixer.
В этой установке также оборудовано 3 стандартных дополнительных емкости для компонентов.
These are the same tanks for extra ingredients, acid emulsifier and
Эти ингредиенты подаются путем открытия этих кранов в такой же гидродинамической смеситель, который был предыдущий.
Again, they're supplied by opening these manual valves and they go into the same hydrodynamic mixer.
Соответственно, когда водная фаза здесь готова, она подается с полной автоматически работают 2 этих насоса вместе в паре, и они подают воду с внешней емкости с концентратом в битумную линию.
So when the system's running, the 2 pumps operate together. They're operated automatically, and they supply water from the external tank and the concentrated blend into the line.
Соответственно, также эта система оборудована, эта установка оборудована датчиками и ручными кранами, что позволяет нам контролировать и регулировать рецептуру.
And this machine as well is equipped with manual adjustment valves that allow us to precisely portion the components for the formula.
И также, как и в предыдущей установке, мы имеем панель, на которой отмечают показатели температуры и давления, что есть важным в процессе работы.
And the same as the previous machine, we have here the same temperature and pressure sensors that are necessary for control of the process.
Кнопка стопа. В принципе, это обеспечивает весь функционал машины.
Also, there is the emergency stop button, and yeah, that's pretty much it.
Спасибо за внимание. Все вопросы вы можете задать в чат. До свидания.
Thanks for your attention, and you can ask any questions that you might have in the text chat. But this is pretty much everything that we wanted to tell you today. I hope you found this interesting. You can, there is this email address right now that you can write your questions to, because we're running out of time to answer those. But worry not, all questions will be answered. Just let us know, write to us. And in the future, we're going to have more webinars on this topic and others. So stay tuned, check our website often. We're going to have announcement on further presentation as well. Again, I appreciate your attention. It was great to have you all here and a privilege to talk to you. And goodbye.